Think about the most ambitious construction project happening in your city right now. Chances are it is a new subway line or a simple highway expansion that has been stalled in political debate and funding delays for the last 10 years. But there is a glaring anomaly on the global map. Right now, a single nation is executing a coordinated, hyper-advanced building spree that entirely defies standard logistical constraints. This is a deliberate effort to leapfrog 100 years of human engineering advancement in a single decade. To understand exactly how they are doing this, we are going to investigate 4 massive, physics-defying pieces of evidence that prove this timeline breach is entirely real. While standard infrastructure projects elsewhere crawl through decades of deliberation, these projects suggest a different set of rules for what is physically and logistically possible. Our first piece of evidence sits high in the mountains of Tibet. Over a stretch of just 50 kilometers, the Yarlong Tangpo River violently drops nearly 2,000 meters in elevation. For generations, engineers looked at that terrifying drop and saw a goldmine of potential energy. But the punishing altitude and ferocious water made building a massive structure there a theoretical impossibility. China decided to attempt it anyway. With an estimated budget of $170 billion, this is the most expensive infrastructure project in human history. When fully operational, the Yarlong Tangpo Mega Dam will generate 300 terawatt-hours of clean electricity every year. To put that into perspective, the previous undisputed global champion, the Three Gorges Dam, produces about 88 terawatt-hours. This new structure multiplies that by nearly 3.5 times. That is enough energy to power hundreds of millions of people without burning a single ounce of coal or releasing any emissions. It is an entire electrical grid sustained entirely by the engineered capture of gravity. This diagram compares standard aviation to the future of rail. A commercial Boeing 737 lifts off the runway at roughly 280 kilometers per hour. During test runs, China's new CR-450 train hit a staggering 453 kilometers per hour. What makes that metric so difficult to comprehend is that this speed is being achieved on heavy steel rails, battling immense friction and weight, rather than gliding through the air. China is currently integrating these aviation-level speeds into the daily commutes of millions, deploying the CR-450 for everyday service on its existing rail network. Think about what that does to the physical geography of a country. A massive 1,000-kilometer trip from Beijing to Shanghai shrinks from 10 hours by car to a mere 2.5 hours. You are experiencing the visceral sensation of traversing an entire continental landmass on the ground at over 450 kilometers per hour, speeds normally strictly reserved for commercial aviation. With 48,000 kilometers of high-speed track, a continental landmass is becoming as interconnected as a single regional transit map. Moving away from earthbound transport, our third exhibit sits deep inside a hidden mountain valley in Guizhou province. This is the Sky Eye. It spans 500 meters across, which is roughly the size of 30 American football fields laid side by side, completely filling the natural basin of the mountains. Following the tragic collapse of the Arecibo Observatory in Puerto Rico back in 2020, this installation gained absolute dominance in global astronomy. There is nothing else on Earth that can match its sensitivity. Its primary scientific function is to act as the universe's largest ear. So far, it has successfully listened to the deep void and discovered over 1,000 rapidly rotating pulsars. But its secondary mission is far more intense. Because of its sheer, unprecedented scale, this massive dish serves as Earth's most powerful, active tool for intercepting radio signals from extraterrestrial intelligence. If you want proof of ruthless logistical efficiency, you have to look at the Pinglu Canal. This is a staggering, brute force feat of engineering that involves carving a permanent waterway directly through solid southern mountains. To understand how rare this is, you have to look back at the century-old nightmares of the Panama and Suez Canals. For over 100 years, nobody attempted a project of this specific nature because the logistics and costs are terrifying. Yet teams are currently slicing a 134-kilometer trench directly through solid bedrock, and they are on track to finish the entire job in just 36 months. The immediate economic result is monumental. It connects an entirely landlocked province directly to the ocean, shaving 500 kilometers off global shipping routes. They identified a massive, immovable geographic hurdle, mapped out a solution, and quietly erased the obstacle from the map. This chart illustrates the true scale of the anomaly. The tallest dam, the fastest train, the largest telescope, and the biggest canal in human history are not happening in isolation. They are spiking on the global timeline at the exact same moment. This is a pattern of execution where the most expensive dam, the fastest train, and the largest telescope are all being deployed at once, altering the global baseline for infrastructure. The disparity in construction speed and scale suggests that the rest of the world is now watching a different era of engineering unfold in real time. So the question remains, is this simply the new normal, or can the rest of the world ever adapt to a competitor that is operating in a completely different physical reality? Out of everything investigated today, which of these 4 mega projects absolutely blew your mind the most? Drop your thoughts down in the comments below right now. If you want to keep exploring the engineering marvels that are actively shaping our future, hit that subscribe button and turn on notifications so you never miss a deep dive. Thanks for watching.
Like, share, and comment. Subscribe.